Again, welcome back to statistics course. Again, this is DSRT 734 course. In these lectures, we're going to discuss about hypothesis testing with two samples. This time, we are going to use a small independent sample. Now, when we say we have a small sample, it means the sample size is less than 30. So in our previous lecture, which is Unit 8, Part 1, we talk about hypothesis testing with two samples using a large independent sample, which means the sample size have to be at least 30. In that case, we use the z-test score, the standard normal table, to find the p, etc. So our main objective in this course, again, we're going to learn how to perform the t-test. Now, if our sample size is less than 30, and instead of using the z-test, we use the t-test. So instead of using the standard normal table, we are going to use the t-distribution table. So here we're going to learn how to perform a t-test for the difference between two means. We have two mean population, this time using small independent samples. Again, when the sample size is less than 30, we consider it as a small sample. So here we said again, if sample of size is less than 30 are taken from a normally distributed population, we use a t-test. So we use the t-test to test the difference between the population means mu1 and mu2. So again, when the sample size is less than 30, we consider that as a small sample size, and it have to be independent. Then we can use the t-test to test our population means mu1 and mu2. Now, there are three conditions that we have to meet, or we say three conditions that are necessary to use the t-test for small independent samples. First, the sample, of course, must be randomly selected. So the samples must be randomly selected. Then the second, the sample must be independent. So that's why, again, our main topic here is using, again, small independent sample. Sample size less than 30. We have two populations. We want to test their hypothesis testing for their mean. Now, each population must have a normal distribution. So first, we need to find the standardized test statistics. Again, here, we are using t-test because the sample size is very small. It's an independent sample size, less than 30, so it's a small size. If it's greater than 30, then it's a large independent sample size. Then we use the z-test or the z-statistics. So this is the formula for it, which is almost close to the z-test formula, but there's slight difference. So we have the difference of S1 bar and S2 bar, which is two samples means. Then the minus the difference of mu1 and mu2, that's the two population means, divided by again the standard deviation. Now the difference of the two formula for the z, remember the z also, we have the same difference of the sample means and the population means, but we divide by what? The standard error. In the t-test, we are dividing by the standard deviation of the population. So here we say the standard error and degree of freedom of the sample distribution depends on whether the population variance are equal. So the variances are equal. Then we say that information from the two samples is combined to calculate a pooled estimate of the standard deviation. And this is the formula we use if the variances of the two populations are the same. So we get N1 minus 1 sample variance square of the first sample. The second sample size N2 minus 1 times the variance of the second sample divided by the sample size for the first sample plus the sample size of the second minus 2. Then the standard error of the sample distribution of S1 bar minus S2 bar will give us, again, our pool estimate of the standard deviation times square root of 1 minus sample size 1 plus 1 minus, 1 divided by sample size 2. So it's the square root of 1 divided by sample size 1 plus 1 divided by sample size 2 square root. Times, again, the pool estimate of the standard deviation, which the formula is given to us here. The degree of freedom, we have 2 items now, 2 samples. So degree of freedom is N1 plus N2 minus 2. Why we need degree of freedom here? Because we are using the T distribution. When we are using the standard normal table or the Z-test, we don't need degree of freedom. We don't need it in the table. So when the variances are not equal, the little bit slight difference of the formula. So here we find the standard error is the variance of the first sample score, variance over divided by the sample size 1, variance of the second sample divided by the sample size 2. Then the degree of freedom will be the smaller one of N1 minus 1 or N2 minus 1. So if the sample size for the first one is less, then that will be our degree of freedom. If the second sample size is less, then that will be our degree of freedom. The smaller of the two different from 1. So when to use the normal or T distribution, we said first question, are both sample size at least 30? So if it's yes, that's what we did previously, the large sample size. Then we use the Z-test. That's what we did in the previous lectures. Now, if it's no, we have one more question to ask. Are both population normally distributed? If it is no, then you cannot use the Z-test or the T-test. You can't use. If they are not normally distributed, we can't use any of them. But if they are normally distributed, are both population standard deviation known? If they are known, then we use the Z-test. If no, are the population variance equal? That's what we check on the T-test condition. If it's no, then we use the T-test with this formula. And if it's yes, we use the T-test with this formula. And actually, this is what we are doing right now. So at the population variance, if they are equal, if it's yes, then we find the pool estimate standard deviation multiplied by square root of 1 over N1 plus 1 over N2. N1 and N2 are the sample size of 1 and 2. Then we know the degree of freedom. If it's no, the variance are not the same, this is the formula we use. So now we're going to put it in words and symbols. So our hypothesis test, the first thing we need to do is to state our HO and HA. Then we have to know our significance level or level of significance, which is the alpha. We need that to draw our critical value regions. Then we identify the degree of freedom and sketch the sample distribution. We can only sketch the sample distribution if we know the alpha. The degree of freedom can be N1 plus N2 minus 2, or the smaller of N1 minus N2 or N2 minus N1. This is what we went through previously. We use the first formula when the variances are equal. We use the second formula when the variances are not equal. That's the variance of the two samples are not equal. We use the second formula. If they are equal, we use the first formula. Then we determine the critical values, which we can determine based on the alpha given to us. So here we are going to use table B. Again, table B means the T distribution table. The T distribution table. Then if we know that, then we can determine our rejection region. Then we find our standardized test statistics. The value we get, if it fall in the rejection region, then we reject it. If it fell under the accepted region area, then we accept HO. Either we reject HO or accept it. So that's where we make our decision whether to reject or fail to reject the HO, which is the null hypothesis. So we're going to see an example soon. So the last option is to explain your decision. So let's see a good example here. This may help us. So here we have a question saying that the braking distance of 8 Volkswagen GTIs and 10 Ford Focuses were tested when travel at 60 miles per hour on dry pavement. The results are shown below. Can you conclude that there's a difference in the mean braking distance of the two types of cars? Use the alpha. So the alpha is given to us to be 0.01. That is the level of significance. Assuming the populations are normally distributed, so we can do, and also the population variance are not equal, so we have to use the second formula for the degree of freedom. So this means we have two samples, and they give us the sample mean for each. And also the sample size, we have 8 Volkswagen, 10 Ford. So 8, and also the standard deviation for the samples are given to us for the two samples. We also know the alpha. So in this case, we can solve this problem. We have to use the t distribution. Why? Because of the sample size. Okay, so this is a very good example to help us get the whole concept together. So we saw our two samples here is giving either GTI or Focus. We have the sample mean for each, the standard deviation for each sample, and also the sample size is less than 30. So this means we have to use the t distribution. How to find the degree of freedom would depend again if the variants are the same. Here we can see that the variants are not the same. So let's start. So first again, hypothesis testing, we get our HO and HA. And based on the claim, we said they are not equal. So mu1 equal to mu2, mu1 not equal to mu2. That's our claim. Alpha was given to us to be 0.01. To find the degree of freedom, we get 8 minus 1, the first. So we have our reject. The alpha is 0.01, so we divide into 2. We get 0.005, 0.005. Then we look for the t value there. Then that was negative 3.499, 3.499. We know degree of freedom is 7, and we know this value, alpha value. So we can get the t from the table. That is the t distribution. Okay, so if we get this finished, now we are going to look for the t value. We enter our formula. And this is again the sample, the difference of the sample mean, and also the difference of the sample size. And doing this again, at the end we get negative 3.496. So we can see that negative 3.496 will be inside the brown area. So our decision will be fail to reject HO. We fail to reject HO. So the significant level is only 1. So we say at the 1% level of significance, there's not enough evidence to conclude that the mean braking distance of the cars are different. So we can't. So we have to accept HO that they are the same. The claim is that the two cars, GTI and Focus, the braking distance are not the same. When we read the question here, the braking distance of Volkswagen GTI and 10 Ford were tested when traveling this. The results shown below. Can you conclude that there is a difference? So our goal is to conclude there's a difference. So that would be the HA. So our HO will be there's no difference. And based on this calculation, we found out that again, there's no difference. Failed to reject HO. We accepted HO on 1% level of significance. That is 99% confidence. So this is a second question, example. Here we have a manufacturer claims that the calling range in feet of his 2.4 gigahertz cordless telephone is greater than that of his leading competitor. So it's greater than. Now you perform a study using 14 randomly selected phones from manufacturer of 16 randomly selected similar phones from its competitors. So now the sample size is less than 30, so it's small. We're going to do it in a small independent. So the results are shown below. At alpha equal to 0.05, can you support the manufacturer's claim, assuming the population are normally distributed and the population variance, this and the variance are equal, so you should be able to, again, use the first formula for the condition of when variance are equal for finding the degree of freedom. So we know the sample mean, we know the sample standard deviation, we know the sample size for both. So let's state our HO. Remember, we said the first one is greater than the second one. So our HO will be less than or equal to, first one is less than or equal to the second one. Alpha is given to be 0.05. The degree of freedom, the first sample 14 plus 16 minus 2. Remember the variance. So this will give us 28. So if we know this, we can have our rejection region. Remember, HA is greater, mu1 greater than mu2. So the alpha go to the greater part. It's 0.05, everything 0.05. So if you find a T with the alpha of 0.05 and degree of freedom 28, you get 1.701. Again, this is from the T distribution table. Then let's do our test statistics. So first we find our standard deviation. Then the answer is 13.8018. Now we find a T. And the T, we have to put the estimated pool standard deviation value. And we get 1.811. Now let's go to our region. 1.811 fall here in the blue area. So now our claim will be correct. So we are going to reject the HO and I'll set our HA claim. So at 5% level of significance, there's enough evidence to support the manufacturer claim, and its phone has a greater calling range than its competitors. So this will be our conclusion for the lectures based on hypothesis testing using two samples to test two populations. This time we are using a small independent sample, which means the sample should be less than 30. And we saw the difference of the two when the variance of the two samples are the same and they are not the same. The degree of freedom, there are two ways of solving it. So again, wish everybody the best and see you in the next lectures. Thank you.